Hey guys, I hope you all are doing good. So in this lecture, we're going to be starting with arrays. Now, we have covered a lot of theory until this point. From now on, we will be covering the actual concepts of data structures, right? So the point is, we will cover obviously the theory part, but then we will move on to solving actual questions, right? But again, theory is going to be super important from now on, because once again, having a good understanding of theory is what's going to help you actually making practical algorithms, right? So I hope that you like this lecture. Now let's start with understanding what are static arrays, right? So there's going to be a series of lectures in which we're just going to be covering arrays, right? Including coding problems as well. So let's start with understanding what are static arrays. Static array is a collection of elements of some type stored contiguously in the memory, right? So the point is, static arrays are basically the arrays that you create inside your function, or I should say inside your main, right? So let's say I'm writing a C code, right? And I declare something like int array of 5, right? This is what I would call a static array, right? I declared it at the very beginning of my code, or I should say my function, right? So this is what it actually is. There are some points that we need to consider. The size is fixed at compile time. The meaning of this is, just like I explained in one of my first lectures, whatever static elements we create or arrays we create, the memory is reserved for them in the beginning of the program, right? So when you execute it, the computer is going to reserve memory for it, right? And it's not going to dynamically create memory for it while the code is running. It's going to create once and then it's not going to do anything about it again. So when you declare something like this is what's going to happen, right? In the computer, there will be an array created with 5 different elements, right? Second point is all elements are stored next to each other in the memory. Now, this is a very important point to understand, right? In the static arrays, all the elements are stored next to each other. Now, what do we mean by that? The point is memory has addresses, right? So think about this. If this is address 1000, let's say the first one is address 1000, then the second one would be at something like address 1004. Third one would be at address 1008, and then fourth one at 12, and then last one at 16. And the point is, why is there some these gaps of 4 bytes? Because we are storing an integer, right? Now, depending on the size, right? If it's an integer, one integer needs 4 bytes to store it. If it was a char, it would just need 1 byte, right? So since this is an integer, one integer takes 4 bytes. That's why the next starts at 104, the third one starts at 108, fourth one at 1012, and the last one at 1016, right? So the point is, all elements are stored next to each other in the memory, and that's very important to understand. Last thing is, elements can be accessed directly using the index, right? So the point is, I can access any element just like this. So one of the examples would be ARR1. This is, let's say I'm trying to access element 1, right? I can just directly do it in a constant time, right? I want to go into deep detail of how this is actually working. When I try to access element 1, right, which is the second element in terms of C code, what's going to happen is my code is going to do something like this. It's going to look at the base address. So in this case, the base address is 1000, plus it's going to take off whatever the index is multiplied by what is the size. Okay, so pause the video, just try to take a look at it, and then I'll try to explain it. Okay, so the point is that when I try to access any element, right, I can access it in a constant time. And the reason is that the computer just needs to do this calculation. It needs to take the base address, it already has it, plus it needs to find the index that we are looking for. So in this case, I'm trying to find index 1 multiplied by what the size of an element is. So in this case, it's going to be 4 bytes, right? So I do 4. So this would give me 104, and that is going to be the index of element 1. So this is element 0, this is 1, 2, 3, 4, right? So I hope that makes sense. Now let's take a look at the memory layout. This is again the same thing. A static array elements are stored contiguously along constant random access. So just like I said, even though the array can be big, I can randomly access it, or I can constant access it if I want to, right? What do I mean by constant access? I can access it in order of one time. Right? I covered the time complexity in the last lecture, so if you have a doubt in understanding what is time complexity, I would suggest that you revisit that lecture once again. But the point is that in static arrays, if I have to access any element, right, whether it's somewhere in the middle or it's somewhere anywhere else along the way, I can just access it in a constant time, which is order of one. And the reason for the constant access is because this is how the computer can perform the calculation. It doesn't have to perform a for loop. It doesn't have to do anything else. It just has to perform this constant, I should say, calculation, right? Okay. Now, the last one is indexing. So in C, array indexes start at 0. Now, this is a very basic point. Now, the point is that in C code and in a lot of languages, the indexes start at 0, right? So this is how the indexes start. So the first element will be stored at 0, second at 1, 2, 3, 4. So one of the problems or one of the mistakes you might make is, let's say you want to access the last element, right? And you try to do ARR 5. This would be incorrect, right? And the reason is that array indexes are going to be from 0 to 4. By this, you're saying you are trying to access another block which does not even exist, right? So you cannot really access that memory using this array over here, right? So always make sure that array indexes start at 0 and they go up till 0 to n minus 1, right? Very important to understand. Okay, now let's move on to the next part. Okay, now let's try to understand some basic array operations, right? These are going to be super important to understand. And after this, after the theory part, I will be starting with the code demo for all these operations, right? So let's try to understand each one. I want you guys to pause the video, just try to take a look at it. What is the operation description and what is the complexity, and then I'll try to explain it. Okay, so the point is that array is not just for storage purposes, right? We also need to access the memory, access elements, delete elements, update elements, etc. Right? So think about this, right? Let's say you manage a group of students, right? You manage their database. Now it's possible that a new student comes in, maybe a student left, right? Or maybe you're replacing a student. Things like that can happen. So you need to make sure that you keep your array or your database updated at all times, right? But how do we do that in the computer? That's very important to understand, right? So let's start with understanding traversal, right? Which basically means visit every element, and the complexity is order of n. So in this case, we are basically talking about the time complexity, right? So I hope that makes sense. Once again, if you have doubt in understanding what is time complexity, I would highly suggest that you visit my time complexity lecture. I've explained it in extreme detail, right? So traversal basically means that in this operation, we are trying to visit every single element. Complexity is going to be order of n. Let's try to understand why, right? First thing, why are we trying to visit every element, right? Let's say somebody asked you to give the list of all students. Then you would have to print the names of all students, right? Meaning inside your array where you store the names, you would have to visit each and every single node, right? And that is why you're going to be visiting every single element. Why is the time complexity order of n? Think about this, right? The only way, let's say this is the array, right? The only way for you to print every single element is going from one to the other again and again, right? So you would have to go to each one again and again. So depending on the size of the array, let's say you have 500 students, that means printing 500 student names. So you can't do anything about it. You would have to start from the first element, go up till the last 500 student, right? If there's just 50 students, then you would have to again do the same thing. It doesn't matter whatever the size is, you would still have to cover the entire array, right? And that is why the time complexity is order of n, which basically means it's going to depend on the size of the array, right? So how would you do it? Again, once again, you would write a simple for loop. And then you would print whatever it is, right? This is kind of how you would do it for the first operation, right? Now let's move on to the next one. Now insertion and deletion are a bit more complicated than the other ones, but still they're very super easy to understand. Right, so insertion basically means add an element at a position, right? Now, just like I said, right, one example could be, let's say you have you have an array, right, which stores multiple values. So let's say you have 1, 2, 3, 4, 5, 6. I'm going to assume that I have extra space left at the end, right? So the point is, let's say that I'm storing these numbers and now I want to add another number into this list at a certain position. How would I do it? Now, if I want to add, let's say 8 at position 3, I should say, right? So this is 0, 1, 2, 3, 4, 5, 6, 7. If I say that I want to ask the element 8 at position 3, then I would have to remove this 4, add 8, and then keep shifting the elements to the next place. Right? So I'll just quickly show you how that's going to work. So first thing, I replace this 4 with the 8, and then I shift all the elements around. Or I should say, I first shift the elements and then I add an 8. Right? So starting with 6, I'm going to shift this 6 to this next position, add a 5 over here, and then shift this 5 as well. Right? So I get 4, and now I have an empty space over at the 3 position, and now I can add an 8 over here. Right? So in very short words, if I have to insert at a certain position, right? For now, we are assuming that we already have extra space, right? In reality, you might have to extend the array if you don't have enough space. But for now, for explanation purposes, I'm just trying to explain that we have an extra space, right? So once again, we had extra space and we wanted to insert at the position 3, right? And we already had elements 4, 5, 6 over there. So how did we do it? We first shifted the elements 6, 5, 4, and then we added an 8 at position 3, which was now empty. Right? So that's how insertion works. Don't worry too much. I'll give you the code for the insertion as well. So you can take a look at it. Okay. So complexity in this is order of n once again. Now I want you guys to try to pause the video and try to figure out why the order is n in this case. Why would the time complexity be n? Okay. So I'll try to explain it, why the time complexity is n again, meaning why does it depend on the size of the array? Think about this, right? Let's say the array was this big. Let's say it had 20 elements, right? What would happen is you would have to, if I had to add an element at the position 3, I would have to shift so many elements again, right? Let's say they were all filled up, only the last space was empty. That means I would have to shift all the elements multiple times. If the array was 500, 600, that involves a lot more shifting of the elements, right? So think about this. Adding at a certain position, depending on the size of the array, I would have to shift the elements again and again, right? So that is why in this case, it also depends on order of n, right? Meaning the size of the array. Now, other case could be if the array is empty, if only the few positions are being occupied, then we can say that it's not going to take that much time. But in general, since in time complexity, we talk about the general case. That's why if it was a bigger array and we had elements until this point, then it would involve a lot more shifting. If the array is small, then it's going to involve less shifting, right? But very short point is that it depends on the size of the array. Okay. Third one is deletion. That is, if you understand insertion, then deletion should be very simple to understand, right? So let's take a look at deletion now, right? Deletion basically means remove an element from a position. So just like I gave an example, maybe some student left your class, so now you have to update the list of students you have. So let's say you knew the index and now you want to remove that student from the list and reorganize your database again. So let's take a look at a small example, right? Let's say I have these values. Let's say I have these values, right? Now, let's say the student at index 2, let's say the student 3 over here decides that he wants to leave the place. So I need to delete this node. How do I do it? I cannot just remove it and leave it empty, right? What I have to do is I need to remove it and then shift all the elements back to their to one index above. So I'm going to shift 4 over here. I'm going to shift 5 to the third index. I'm going to shift 6 over here, and now I'm going to have a last index empty. Right, so I hope that makes sense. Just a quick summary of insertion and deletion once again. In terms of insertion, when I was trying to insert at a certain position, I would have to first shift all the elements after it, and then when the position is empty, I can insert it. In terms of deletion, if I'm trying to delete an element at a certain position, I would have to shift all the elements to the left hand side, right? Once again, this is going to be order of n, because think about this, right? Depending on the size of the array, if instead of 5 there were 20 elements, then we would have to shift all of them ahead, right? If it was 500 elements, then that would involve shifting all the elements, the 300 or 400 elements after that index to the left side, right? And in terms of insertion, that would involve shifting all of them to the right side. That is why it's going to be order of n for both insertion and the deletion operation. Okay. Now let's try to understand update. Update is very simple to understand. Point is, if we want to change a value at a position, right? Let's say a student has updated their name or some details, so you want to update their address, right? Or any information. How would you do it? You can just access it, since just like I told you, static arrays have they have constant access, right? So let's say if this is ARR, right? I can just do ARR 3. Let's say I want to access element at index 3, right? Then I just have to do ARR 3 and then change it to 7, right? So let's say I had to change the value. What this would result in is this 5 would change to 7 now, right? So update is very simple to understand. I hope that totally makes sense. Last one is search. Again, very simple to understand. Doesn't involve much. It just basically means finding an element, right? Let's say you're trying to find details of a student, right? But you don't remember their index. If you know the index, then you can constantly access it. But in this case, let's assume that you don't know the index. You're trying to find out. You have to search the student in the array. How would you do it? You would have to write a for loop, kind of like this, and then basically write an if statement, right? If you're not able to understand this part, don't worry too much. I will give code examples for this as well. But the point is, in terms of search, let's say you're trying to search for a student, you would have to create a for loop and then search that student in the array, right? Once again, this is going to be an order of n. The time complexity is going to be order of n, because it is going to depend on the size of the array. If it's a big array, then, and let's say the student is at very end of the array, it could take a lot of time. If the array is small, then the time taken would be a lot less, right? So I hope you were able to understand all these operations. Now, this is just a quick overview of these operations. Once again, we will go into a good detail in some next videos as well, right? So now let's move on to a code example. Okay guys, let's take a look at a clear example, right? So I have a array.c over here. If you guys want, I can give you a GitHub link for this code as well, right? So this is a very basic example. First thing is, let's try to go through each one, right? Traversal, search, insertion, deletion, and update, right? So first thing is, I declare an array, and I'm declaring the size to be 100, right? Point is that I'm creating a big array, but I'm still just storing 5 elements inside it. So what's going to happen is the rest of the positions going to have garbage values inside them, right? We cannot access them. They're going to be just garbage, any random values. We can access them, but they're not really helpful to us, right? This n over here is just a declaration of what is the number of elements inside our array. So since we have 5 elements, that's why I've declared n equal 5, right? These are some other variables that I've declared for usage. But let's start with the first one, right? First thing is, I'm printing the initial array. So what's going to happen is the executable is going to print whatever the initial elements are. So it's going to print 10, 20, 30, 40, and 50, right? I will also show you the code execution as well, right? So don't worry about that part. Okay, so let's take a look at the traversal, right? This is what the traversal code looks like. First thing is, this is how we traverse it. So I am printing every single element, print element at index %d. This is how you print elements, right? I hope you are able to understand how C code works. If not, I would highly suggest that you go through some C code lectures and then get back to this video, right? But the simple point is that I'm saying that print element at index %d. %d is basically I want to declare what index I'm at currently and then declare what the value is, right? So this is going to be the index and this is going to be what the element at that is. So traversal, just like I said, is order of n. This is the search operation. So what I've done is I've created a print statement so that I can enter an element to search and then the computer is going to search for me, right? The program is going to search for me. So when you enter a certain element, it's going to scan into this key over here and then there's a for loop for the search, right? So this is how we do it. I create a for loop, I go until the index n, and then I say that if the array element I, meaning if any of the array elements is equal to the key, then print it, right? And if it's found, then we declare it 1. So the basic point of this code is we create a for loop, we check a if condition to see if we find the element. If not, then we just print that the element, we were not able to find it, right? So search is a very simple code. Traversal again is very simple. They're just very simple for loops. Third one is the insertion one. Now this is a bit more tricky to understand. Let's try to understand exactly what's happening, right? So first thing is, I take in the input of a position, right? Whatever position I want to delete, and what position I want to add it, and the second is the value I want to add, right? So these are the two values that I'm taking in as the input. So next what I do is I take whatever the input was done by the terminal, using the terminal, and then store it in the position and the value variables that I declared, right? These are the variables that I declared in the beginning. Okay, so what's happening is I check if the position is less than 0 or it's greater than n. Now this is just a recheck, or I should say like I want to make sure that I don't break my code, so I add these extra safety conditions, right? That's exactly what we are doing in this case. So what we do is, if position is satisfied, so if we are in the safety block, we go through the for loop, right? And if you look over here, this is the for loop for shifting right, right? So first thing, just like I said, I'm gonna have to go to the position where I want to the element, and then whatever elements are at that position, I want to shift them one by one to the right side, right? Then I add the new value at that position and then increase n plus plus. N once again is storing the number of elements, so I need to update the value as well, right? Last thing, I'm just printing after insertion what are the elements, right? Now in deletion, the code is very simple once again, but instead I once again check the position to make sure that it's not less than 0 or it's greater than n. Otherwise, I would not be able to access it, right? So if not, then I create a for loop. I shift the elements to the left, right? So basically, I don't have to delete the element. I'm just kind of like shifting all the elements to the left. So whatever position I shift to, the elements at that position would be gone, right? They would be updated. And after deletion, I update the n value as well. So n minus minus, let's say earlier I had 6 elements, right? Now after n minus minus, n would be 5 again, right? Last one is update. Now this is again very simple to understand. First thing, I enter the position, right? And a new value. So scan it, meaning input those values, whatever were given by the user, right? Check condition. This is just a safety condition once again, and just update the position, right? So this is a very simple explanation of whatever the position is, add the new value at it, right? So I can show you the code demo of how this basically works, right? Now, just to clear out, this is how we run it. Now, this is the GCC command. Just to give you guys a quick overview, this is the compiler, the wall meaning some warnings. This part basically means that I'm using a standard C99 version, and this is the name of my program, right? Just like I explained in my first lecture, when I do this, an executable will be created, right? And it's by default named a.out, but you can change the name as well, right? If you want to learn more about C code, I would highly suggest that you should visit some videos or I probably assume that if you are at data structures, you probably already have a good idea of how C code works, right? Okay, so now in order to execute the program, I'm going to do ./a.out, and the code is running, right? So just like I said, first the computer has given me an initial array, right? And it has shown me how the traversal works, right? So at index 0, we have 10, 1, 20, 2, 30, 3, 40, 4, 50. Now, let's say I want to search an element, right? Let's say we try to search 40, right? It has found it, and then it said element 40 was found at position 3. Now let's try to do insertion, right? Enter a position and a value. So let's say that at index 1, or I should say index 2, I want to add an element 35. So if you look at this over here, right, this was the initial array, or I should say this one, and I wanted to add an element at index 2. Remember, we are using the element indexes starting at 0. So index 2 basically means add at position 3 in this case, right? So what happened is we added the 35 and we shifted 30, 40, and 50 to the next positions, right? Now let's take a look at deletion. Whatever we want to delete, let's say I want to delete the element 2 again. Once again, we are back at the same array we had, right? So it deleted 35 and then it shifted 30, 40, and 50 to the left hand side. Let's do an update now. So let's say enter the position. Let's say I want to update position 4, and then the new value is 55. So once again, now if you look at it, at position 4, we had 50 stored, and now it's 55. Right? So I hope you were able to understand this code, and that's pretty much it for this lecture. I'll see you all in the next video.